Hello everyone. Today we're going to be learning about power sources, in particular the power sources that are used to produce electricity. We're also going to be looking at some of the energy transformations that occur within an electric generator. Now a generator, as we know, is a device that turns mechanical energy, that is kinetic energy, into electrical energy. The first generator was invented in the 1800s by a fellow named Michael Faraday, who discovered the principles of electromagnetic induction, which allows the transformation of mechanical energy to electrical energy. Now, the design of generators has improved over time, and currently we use a steam turbine generator in order to produce electricity. So how exactly does the steam turbine generator work? Let's take a look. In order to produce electricity with a modern generator, we need to spin a magnet at high speeds. The faster we spin it, the more electricity we can get out of it. This relates to the principles of electromagnetic induction. But it will also mean that the magnet won't spin freely. We need to constantly provide it with energy in order to keep it spinning. Otherwise, it will slow down very quickly. So the method produces an AC signal, or alternating current signal. There are ways of producing generators which allow a DC signal, that is direct current, but AC signal is more commonly used. Now the magnet is spun by a turbine. A turbine is a device that spins when air or steam is blown through it. So the steam from the turbine is going to be produced in a boiler heated by coal or gas, or by the heat of a nuclear reactor. So what will happen is that the steam produced, which will be moving very fast as it's produced, is blown through a turbine, looking much like this one. And as it blows across the blades of the turbine begins to spin. And the spinning is, of course, what turns the magnet. And the magnet produces electricity. So the steam is condensed back into water and recycled once it's been used to turn the turbine. Now in New South Wales, we use a lot of coal to generate power. In fact, 80% of the power generated in New South Wales is generated by coal generators. The main power stations in New South Wales are located in Hunter Valley, Lake Macquarie and Lithgow. Our generators can convert about 36% of the coal's energy to electrical energy, which doesn't really sound like a huge amount. But remember that by burning the coal, we produce enormous amounts of energy. So even if we can only turn 36% of this energy into electricity, we still have a lot of electricity to go around. Now, an increasing number of countries are using nuclear power instead of fossil fuels in order to produce electricity. So the uranium fuel in nuclear reactors produces a very, very large amount of energy, much larger than the energy of, say, coal. The energy is absorbed by a coolant, which carries heat out of the reactor, and that coolant is used to heat water, so that the water itself doesn't become radioactive. The coolant heats the water to boiling point, where it becomes steam and blows through a turbine, just the same as if we were heating the water with coal fire. Now, the reason that people use uranium instead of coal is because it contains much more energy per kilogram than coal, and makes it a far more attractive power source. We can see that illustrated in this photograph. The huge mountains of coal in the background of the photograph only contain the same amount of power as the few pellets of uranium in the foreground. You can see now why uraniums are a more attractive power source than coal, simply in terms of the energy density, that is, the amount of energy that they contain. One of the problems with nuclear power plants is that the spent radioactive fuel is radioactive and cannot be safely disposed of very easily. Radioactive materials are able to be damaging to living things if living things are exposed to them for long enough. So nuclear disasters are one of the other drawbacks of using nuclear reactors, and although they're very, very rare, occurring perhaps 2 or 3 times in 100 years, they can be extremely destructive and produce a lot of danger in a very wide area. So another alternative to producing electricity, if we're not going to use coal or uranium, is using wind generators or water generators. So these will produce less energy than burning coal or using uranium in nuclear reactors, but they're renewable resources of energy. We won't run out of wind. So these generators use wind or water to turn a turbine instead of producing steam that will then turn the turbine. So these wind generators that we can see in this photograph over here have long turbines like a windmill, and when these are turned, they spin a magnet which will produce electricity. So the generators do not produce pollution, and they do not produce any dangerous waste products like coal and uranium do. And of course, they also won't run out. Now, water generators don't have to be powered by just one source. There are water generators that can be powered by rivers, by the flow of the water in rivers, by ocean tides as they come in and out, or just by waves as they roll up and down. There are 7 hydroelectric power stations in the snowy mountains of Australia, and these are responsible for the rest of the power in New South Wales. Another way that we can get energy to produce electricity is from light. By using devices called photovoltaic cells, we can transform light energy directly into electrical energy without any intervening steps. These are quite expensive to produce, and they're not very efficient. Most photovoltaic cells will convert less than 30% of the light energy they receive into electrical energy. The best photovoltaic cells can produce slightly more, but they're still under 50%. So energy obtained during the day has to be stored up because obviously the solar panels won't operate at night. So we take this energy and we store it with a large battery. Finally, we can use geothermal power as an energy source. The Earth's mantle and crust contain a lot of heat energy. That's why the core of the Earth is molten. So if we have a geyser or hot rocks underground, we can use either one of these in order to heat up water and produce steam. Or we can simply use the steam itself to turn a generator. So the steam can be used for direct heating as well, instead of using it to produce electricity and then later to produce heating. So geothermal energy is not a very well used amount of source of power yet, but in the future it may provide a very nice way of gathering energy. Alright, so that's the end of the theory. We've learned about a number of different power sources and how we can use them to produce electricity. Let's go on to some questions.